All right, so hearing, the sense of hearing, this is a mechanical sensation, okay? So we need to kind of look at the anatomy of the ear for just a second to see what's going on here. So if we look at the ear here, the inside of the ear, there's three parts of it. So there's the outer ear, the middle ear, and the inner ear. The outer just is the pinna, so the ear part, and then the external auditory meatus. The middle ear goes from the tympanic membrane over to the oval window. Okay, the middle ear is filled with air. The inner ear is filled with fluid. So this is the tympanic membrane. Or the eardrum, however you want to think of it. These are the ossicles. These are the little bones that are within the middle ear. So the malleus, incus, and the stapes, which we will talk about in a second. Those are our ossicles. And then in the inner ear, we have this area called the vestibule. And the cochlea here, which is the hearing receptor. And then over here, we have the semicircular canals. Semicircular canals. And those are for balance. So in hearing, we are responding, or your ear is responding to sound waves. And it is mechanical because sound waves come into the ear and they hit the tympanic membrane. And when the tympanic membrane gets hit by sound waves, it starts to vibrate. And as it vibrates, it is attached to these little ossicles, the little bones, little tiny bones in there, and those start to vibrate as well. Those ossicles that vibrate actually amplify the sound by about 22 times. So sound amplification. So by the time it gets through the malleus to the incus to the stapes, we've amplified that sound 22 times. The stapes is attached to something called the oval window. And it is another membrane, basically. And to the other side of it, the membrane is on that vestibule, and to the other side of it is the fluid-filled inner ear. And this vestibule, which is attached to this snail-looking thing called the cochlea, is fluid-filled. And in the cochlea, there are these cells called hair cells. And as the stapes is moving back and forth, it's causing waves now within the fluid. Okay? So that fluid, as it comes in, it hits those hair cells, and that makes the hair cells bend. All right? When that happens, it opens some gates. So on these hair cells, these little hair things, are potassium gates. And I know that seems backwards. You'd think it would be sodium, but it is potassium gates. Because remember, we're not in a regular place. We're in an area that's fluid filled with endolymph and perilymph. And has a different ionic consistency than what normal cells are sitting in. So this fluid out here is full of potassium. So when those potassium gates open, potassium flows in, and that actually causes an action potential. And that action potential flows down here into or to cranial nerve 8, the vestibulocochlear nerve. So you can see it right here coming out of the cochlea. That is the cochlear arm of the vestibular cochlear nerve. So that action potential goes down there and goes to the vestibular cochlear nerve and then goes into the temporal lobe where you get conscious sensation of sound or hearing. All right. The semicircular canals here are also filled with fluid. So those canals look kind of like that. And they're fluid filled, and they contain these weird rocks called otoliths. And every time you move your head, those rocks move, and they help you to maintain balance at any position. So when you move your head, it might take a second to get used to being where you are as those little rocks are flowing down the semicircular canals to that area to make you feel balanced. If you spin around, like you twirl around right when you stop, you still feel like you're moving because those rocks are still moving and settling around those semicircular canals. So the whole apparatus is fluid filled. Again, if I put my line here, what's above here deals with balance with the rocks in the semicircular canals and all that. And then down here is the cochlea, and that has these little hair cells, and that deals with sound.